Okay, this video is about step 3 of hypothesis testing, where we're going to compute the test value. Okay, so you should, if you're watching this video, you should already know how to state the hypotheses and find a critical value. Okay, so I'm just looking, seeing what page I need to go forward to. Right. So here's our formula for finding the test value, and it's not a new formula. Okay, we've used this formula before in our sample mean problems. All right. So we're going to standardize. We're going to find a z-value. So here is our first problem. We'll work through this problem in full, and then you really need to do practice in this until you feel comfortable with it. And I do have a lot of practice in this PowerPoint. So let me maximize this so I can write on it. Okay. So here's our problem. The researcher thinks the average salary of assistant professors is more than 42,000. Sample of 30 assistant professors has a mean salary of this. And then they give us our alpha, and they want us to test the claim that assistant professors earn more than 42,000. And they've given us the standard deviation. Now, for this one, the null and alternative, the null is actually a little bit confusing. Okay, what we know is this 42,000 average. Okay, so our null here is going to be that mu equals 42,000. Okay, and the researcher's claim is that professors earn more than. Okay, that's stated twice, this idea of mu being more than 42,000. Okay, so you should be able to tell it this is going to be a right-tailed test. Yeah, you know that from the alternative hypothesis. Okay, so the rejection region is going to be in the right tail. So our next step is to find the critical value of z, which is going to be right here. Oh, don't do this to me, stylus. Okay, and this is our mu. Okay, so our critical value, well, they told us that the alpha is 0.05, and it's a one-tailed test. So all we have to do, we'll go to our table. Okay. It's a one-tailed test, and our alpha is 0.05. So one-tailed, 0.05. Our critical value of z is going to be 1.645. Okay, so go back and write that down. So our critical value of z is 1.645. Okay. And the critical value separates the rejection region from the non-rejection region. So this is going to be our rejection region. Okay. So next we have to compute the test value. Okay. So if we look back on the previous slide, which actually you really should have the handout, you know, if you attended class. If we look back on the previous slide, our mu was 42,000. Okay, sample size was 30. The average of that sample was 43,260. And our alpha was 0.05. Okay, and our standard deviation of the population was 5,230. Okay, so then it's just a matter of slotting the numbers into the formula. So our x bar is 43,260. We're going to subtract 42,000 from that. And then 5,230 divided by the square root 30. So we're going to get our test value of 1.32. Okay, now all we have to do, we know our test value is 1.32. Oh, come on, don't do this to me. I want to keep. Okay, we'll go back here. Our test value is 1.32. Right? So all we need to do, I'm going to write that down here. Test value equals 1.32. So all we do is we just locate where that test value would be in the standard normal distribution, and the test value would be, let's say, about right here, wouldn't it? Okay, so it's not in the rejection region. The test value is in the non-rejection region, so therefore we do not reject the null. Okay, so it's as simple as that. You state your hypotheses, you find your critical value, the critical value divides the rejection region from the non-rejection region. Then you calculate your test value and you see where it falls on that standard normal distribution. If it falls in the non-rejection region, you do not reject the null hypothesis. Now, if we had got a test value of, let's say, 1.7, that would fall in the rejection region, and so then we would have had to reject the null hypothesis. Okay? So our decision here, okay, our test value, as I wrote on the previous slide, our test value was 1.32. Okay, our critical value was 1.6. I have it written as 1.65. Okay, I think that the version of the t-table we're using this year is a bit more accurate. Okay, so the test 1.32 is not in the rejection region. So therefore, we do not reject the null. That's it. Okay? And then this last step, summarize the results. Is there enough evidence to support the claim of the alternative hypothesis? Okay? And no, there isn't. No, because we did not reject the null hypothesis. Okay? So the evidence really supports the null hypothesis. Okay? And you have to remember, as I said in class, hypothesis testing, it's really analogous to guilty and non-guilty. The result is you either reject the null hypothesis or you do not reject the null hypothesis. Okay, you never confirm the alternative hypothesis. Okay, we either reject it or do not reject it. Okay, so in this video we've gone through the 5 steps, all the steps of hypothesis testing, and really you need to do more practice if you want to get this down. We've done the traditional method of hypothesis